just select branch name from loan. So that basically gets us all the branch names in my loan table, right? So those are multiple rows. So we have multiple rows being output as one thing. And then we have max amount. Let's add that back. And then we have max amount that is just one value. So one attribute has multiple rows, and the other attribute that we want just has this one value. So there is no way to display that particular information to you guys, right? So it has to be like a table. It has to be a single value or something like that. We can't have one table, one row of or one particular attribute having multiple rows and one particular attribute that just has a single value, right? So yes, a group by would actually solve this particular issue. So most database systems would actually give you an error. However, MySQL and MariaDB are completely fine with this particular statement. So we can actually configure MySQL such that it does not, it still considers this to be an error. However, as of now, the current implementation of MySQL just gives you a result for these things. Okay, very good answer. Moving on. Let's take another example. This does actually work. Select min amount as min amount and max amount as max amount from loan. So this basically finds the maximum amount in my table of amounts in my loan table and minimum amount in my loan table, and then gives us this particular result as min amount and max amount being these two particular values, right? So this is fine. But just one thing to remember in this case is um, in order to find the minimum or the maximum, you can imagine if you're writing code for it, let's say that I want to find the minimum value of the maximum value in an array, right? So if I say that, so how do I say this? So basically we want our code to talk to databases as little as possible because it is a very expensive operation, right? So if we want both the minimum and maximum from the table, we can write it as a single query like this. However, if we want the minimum now, and let's say later down the line, we want the maximum, that would require that we parse the entire database again to get this result. But if we just write it in a single query like this, then your databases are smart and basically they would just parse the entire database once and just give you the min amount and the max amount at the same time. So this is not relevant when we have smaller tables, but imagine a table that has trillions of values, right? So basically that would be useful for us to parse our database as less as possible when we are performing these aggregate operations. Okay. Okay. Eliminating duplicates. So we can use the distinct keyword to eliminate duplicates from the table. So let's say that I want the number of branches that currently have loans in my loan table. So if I say that, so note the question carefully, I want the number of branches that currently have loans. So I just want the count of branches that have loans. But if I just say select count branch name from loan, that basically would count all the branch names from loan, this will not work. Now, why won't it work? Because multiple people can have one single branch can have multiple loans, right? So a particular branch, so in this scenario, that is not the case. We don't have an example here, but you can imagine that a particular branch can have multiple loans. So if we perform this particular operation or query here, note what it does. So select from loan, count all the branch names and give me the result, right? So this would basically count all duplicate branch names as well, right? So essentially this query ends up being, give me the total number of loans in my loan account or my loan relation, right? So give me the total number of loans, but we don't want that, right? We want the number of branches. So unique set of branches that currently have loans. So for that, we can apply the distinct operator on branch name before applying to count. And we can say select count from distinct branch name from loan, right? Okay. Any questions? Okay. We also have something called count star. So count star essentially is basically counting all the number of tuples or the number of rows in your table, right? We are not actually counting any attribute particular rows, but we are just counting all the tuples. So for example, this can be a use case for cases where we just want to know the number of entries in a table, right? So we can say count star from this table, and that would basically give me the number of entries from a table. Maybe I just want to display the table. And so if it's a smaller table, let's say 100 rows or something, I can check with count star, get me the number of rows in that table. If it's lower or a smaller table, I can just print out that table. If it's a larger table, I may have to like print out a subset of that table, right? So a count star is essentially the use case is different for different problems, but essentially it counts the number of tuples in a particular table or a value. I don't talk about this thing, right? Okay. So another thing that I don't think I have the slides for here, but essentially, let's say that I have this huge table, some table that contains the name of all students in this university and what classes they take, blah, blah, blah. And let's say that I want the first 10 rows of that table. So for that, we would use some keywords such as select star from university limit 10, right? So let me just type that out in a notepad somewhere. So we would say something as select star from university limit 10. So that would actually get me the first 10 rows of my table. We also have something called offset that basically says offset by 10 and then get me the next 10 rows. So 10 to 20 rows from my table, right? So we also have keywords like limit and offset. Okay. So count again allows us start because it can count the number of rows. But if you think about it, average star, min star, max star, those are all aggregate operations as well. But those don't make sense. I can't actually average out multiple attributes altogether. We can average out a single balance amount, but we can't average out all rows together for all attributes. So average star, min star don't really make sense. Another thing to remember is count behaves differently in different cases. So in terms of the null values. So when I say count star, it would count all the null values as legitimate values as well. So even if a row has all null values, count would actually count that particular row as a single row and give you the number of rows. However, if we are performing count on a particular attribute, let's say branch name, and that is just a single attribute, if that attribute has some null values, in that scenario, count will ignore those null values, right? And just count legitimate values. So keep that in mind when you're talking when we are talking about count star and count for a particular attribute. Okay. Now, grouping. So we talked about grouping when we talked about relational algebra, grouping and aggregate stuff. So here we can group them as well, basically the same thing. Let's say that we want to find out the average loan amount for each branch. So that means we need to group by branch names and then find the average amounts for each of those branches, right? So essentially we do the same thing, select branch name average amount as average amount from loan, group by branch name, right? And basically we are grouping by branch names first and then finding those amounts in a particular branch name and then averaging those out. So if I run this in MySQL or MariaDB, let's say MySQL because one is the default. I just said MySQL. So if we run this in MySQL, essentially we can see that this particular result is sorted, right? So it isn't necessary that the original data was sorted like this, but if you see that in terms of branch names, this particular result is sorted. So this is something so note that we did not have any order by clause here, but this is the output from your MySQL database if we run this query. So the reason for this is essentially how MySQL does this particular group by operation. So MySQL essentially sorts the results. So imagine grouping by the similar things. One idea would be to sort all of those results and then find common values one after the other, right? So MySQL takes that approach. It would sort out all the results first and then group by those names. But so MySQL, that is why the result of MySQL when we perform a group by often ends up getting a sorted result. However, if we are using some other database systems such as Postgres, it will not give you a sorted set of results because we are not specifying it. And secondly, Postgres uses some form of hashing to maintain the list of all common names and uses those hash tables to actually compute the average amount and those group values, right? So it's a different implementation of the same group by idea. And that is why different databases can give you different orders. So that is why what we say that we can't guarantee unless otherwise specified, we can't guarantee the ordering of the results. Okay. So we can also group by multiple attributes as well. We looked at grouping by just a single attribute till now, just group by branch name, but we can also group by multiple attributes. We can say that how many accounts does each customer have at each branch, right? So group by branch, group by customer name, and that would get you groups for both customer and branch. And then basically we count the tuples in each group. So it should not be that hard, and I would suggest that you write out the SQL statement yourself and try it out. It should be a really interesting thing. But we can actually group by multiple attributes as well. Okay. So, right, this one. So remember that we said that a group by or aggregate operation as in relational algebra look like this fancy G, where on the left hand side we had the list of group by attributes, that the attributes we are grouping by, and on the right hand side we had all the aggregate operations that we were performing on those attributes A1 through AM, right? If you remember, what was the schema, resultant schema for a group by aggregate operation in relational algebra? What was it? So the resultant schema was all the group by attributes followed by all the aggregate function attributes, right? That was my resultant schema for my group by function. Sorry, for my aggregate and grouping function. In SQL, however, you need to specify in the select statement what are the attributes that you want in the final result. So that also means that if I'm grouping by G1 and G2, I have to specify G1 and G2 again in my select query. So we need to say select G1, G2, blah, 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 and all the aggregate functions from R1, R2, where some predicate P group by G1, G2, and so on, right? So we need to specify G1, G2, and all those grouping by attributes again in our select clause. However, note that this is not necessary. This is writing these two, writing the group by attributes in two locations is not necessary. And even in relational algebra, we did not have to. But in this scenario, we might not want those attributes in the results. Rarely have I seen that we did not have to write